Hi everyone, in this recording we'll be going over the law of cosines. Our goal is that by the end of this presentation you'll be able to use the law of cosines to solve oblique triangles and model and solve real life problems, and you'll be able to use Heron's area formula to find the areas of triangles. So here we're given the law of cosines where lowercase a, b, and c are side lengths of a triangle and capital A, B, and C are the angles of that triangle. So for the standard form we have three different ones. The first one being a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. The second one being b squared is equal to a squared plus c squared minus 2 times a times c times the cosine of b. And the last one being c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of c. And those were the standard forms. Now for the alternative forms, they're the same thing, but just isolating the cosine of A, cosine of B, and cosine of C. So I'll just show how they went from this form to that one. So first we can add the 2bc term, the 2bc cosine of A term. Now on the right hand side, it will cancel out. Now we can subtract by a squared on both sides. And on the left hand side, it will cancel out. Now to completely isolate the cosine of A, we can divide by 2 times bc on both sides. So on the left hand side it cancels out, and that is how they got this form right there. And then you just repeat the process for the other two forms. Now depending on what you're given and what you're told to solve for, that'll dictate which form you'll be using. So for our case, we are told to solve for the angle B, and we are given the three sides. So side A has a length of 5, side B has a length of 7, and side C has a length of 8. So we can use the formula, the cosine of B is equal to a squared plus c squared minus b squared divided by 2 times a times c. So plugging in all the values on the right hand side, we get that the cosine of B is equal to 40 over 80, or the cosine of B is equal to 1/2. Now to find the angle, we take the inverse cosine of 1/2, and that gives us that the angle B has a measure of 60 degrees. Now here's a real-life application of the law of cosines. So we're given a Coast Guard ship leaves its port base to respond to an emergency. The ship sails straight east for 40 miles, so this portion right here. Then it turns sharply and sails southeast for 20 miles, this length right here. The captain makes a precise angle turn of 60 degrees from its original path, so right here, this angle. The ship finishes its mission. How many miles is the direct shortcut straight back to the port base? So we need to find this length right here. So first we label all the values that we were given. So the side A is 40 miles, the side B has a length of 20 miles, and the measure of angle C is equal to 60 degrees. So first we can plug in our trip details. So using the form c squared is equal to b squared plus a squared minus 2 times a times b times the cosine of c. We get that c squared is equal to 1,200. Now taking the square root, we get that c is equal to approximately 34.6 miles. So that is the length of the shortcut straight back to the port base. Heron's area formula is named after the Greek mathematician Heron and can be established by the law of cosines. So if you're given the triangle with the sides A, B, and C, then you can find the area of that triangle by taking the square root of t times t minus a times t minus b times t minus c, where t is equal to the sum of the lengths, so a plus b plus c divided by 2. Here we're told to use Heron's area formula to find the area of this right triangle. So we're given that the side A is equal to 3, side B is equal to 4, and side C is equal to 5. So first we solve for S, where that is equal to a plus b plus c divided by 2. So 3 plus 4 plus 5 is equal to 12 divided by 2, and that is equal to 6. So now we can plug in that value in our formula. So we have 6 times 6 minus a, so 6 minus 3, times 6 minus 4 for b, and 6 minus 5 for c. So we have 6 times 3 times 2 times 1. We get that the area is equal to the square root of 36, which is equal to 6. Now we can double check our answer because we are using it in a right triangle. So in our case, the base would be the side 4 of length 4, and the height is the side length of A, which is equal to 3. So we'll have 1/2 times 4 times 3, and that is equal to 6.